Okay, example number 3, we just have a single function. So let's talk about this. The period comes from whatever we're taking the sine of. This theta, is there a number in front of it? No, there's not. So our period is just 2 pi divided by 1, which is 2 pi. That's our left and right. To take our axis, we take that number and divide by 4. And so that's going to give us what we started with in the first place. So this does not change the period at all. This is like a normal period is 2 pi. So this one's pi, this one's 2 pi, this one's pi over 2, this one's 3 pi over 2. And the same in the negative direction. Okay, the amplitude. The amplitude is the number in front. That number in front is 2. All right, our amplitude of 2 means that 2 is going to be the highest we go. We probably could count by 2 boxes, which is what I've been doing, except that in a minute we're also going to have a vertical translation, and so I don't think I want to do that. I think I just want to count by ones so I have enough space on my graph to do what I need to do. All right, let's talk about phase shift. Phase shift is what's going on inside those parentheses. Is there a plus anything or a minus anything? That would move it left or right. No. There's no phase shift. Vertical shift is what's on the end, and there is one of those. It's going to be going up 1. All right, well, that's going to mean something for our graph. What that is going to mean for our graph is, we usually start at 0, 0, and we go up. Well, we're not going to start at 0, 0. We're going to move everything up 1. So instead of starting at 0, 0 and going up, we're going to start at 0, 1 and go up. And that is going to be the middle of our graph. I'm going to make a little dotted line here. I kind of call this a highway. So the middle of our highway is at 0, 1. Then I have an amplitude of 2. So it's going to start there and it's going to go up 2 units. I'm going to draw the outer lines of my highway. All right, so the outer lines of my highway are up at the 3 and down at the negative 1. How did I get that? Well, because it has an amplitude of 2, but it starts at the 1. So it starts at 1 and it's going to go up 2 and it's also going to go down 2. If I draw this highway, it will help me stay in between the lines, just like the lines on the highway help you do that. So it's going to help me stay in the lines and figure out where I'm going. It starts at 0, 1, and it goes up from there. The period is 2 pi. I divide that by 4. It's going to give me my 4 stops along the way, my pi over 2, etc. So I'm going to go up 2 and over pi over 2. And then down 2 and over pi over 2. Down another 2, and then up 2. So I'm ending at the center of the highway, just like I started at the center of the highway. So my graph is going to look something like this. On the left-hand side, it's going to have that same pattern on the right. Excuse me, this is the right-hand side. It's going to have the same pattern on the left. Do you see how it has 4 parts to it? Every period has 4 parts to it. So up, down, up, down, up. There's 4 parts. Okay, so that is our graph of 2 sine plus 1. 2 is the amplitude, plus 1, moved it up 1, and we keep our wave, keep it in the lanes of the highway, and that helps us out there. There is one more sine graph on the next page. Let's go to the next page. There's a lot going on here, right? Amplitude is 1/2. Our period is if there's any number being multiplied in front of the x or in front of the theta, there's nothing there being multiplied. So that means that's easy for us. It's 2 pi. That's what we've been doing. We're familiar with that. The phase shift, left or right. Look, we're moving it left pi over 4. So we'll have to figure out what that means. That's new to us now. The vertical shift is anything up and down? Nope, nothing. All right, let's set up our x-axis. It's a 2 pi. We divide that by 4, so we're counting by halves, pi over 2s. Okay, so we've set up our x-axis by counting by pi over 2s in the positive direction and in the negative direction. Our amplitude is 1/2. We can set our axes any way we want as long as we label our scale. I think since we've been counting by 2 boxes is 1 unit. Let's go ahead and stick with that because I think that'll make it a little bit less confusing. You could count by anything you wanted to, but this will give us some space to fit in what we need to fit in. Okay, we need to think about where we're starting. The parent function would start at 0, 0 and go up from there. However, we don't have a parent function. We have something with some transformations on it, so we need to move it around. Okay, is it going to move up and down at all? No, it's not. But it is going to move to the left pi over 4 units. So this is pi over 2, so pi over 4 is going to be right here. So I'm not using that one that I had used before. I'm going to scoot over by pi over 4 units and start there. My amplitude is 1/2, so I'm going to start here. I'm going to go up 1/2. And notice 1/2 is like 1 box here. But I still am going to go over pi over 2 units, which was 2 boxes to the right. So I'm going to go up 1 box over 2 boxes because that's going up 1/2 and over pi over 2. And then I'm going to repeat that same pattern that I've been doing. So I'm going to go down and over 2, down and over 2, up and over 2. So I go up, down, down, up. And I'm going to do the same thing in the other direction. Down and left 2, up and left 2, up and left 2, down and left 2. So I have, let's take a look at what we have. We started at the pi over 4. If you want to label that, negative pi over 4, that's where we started. We went up from there. And so up, down, down, up, and down, up, up, down. So we have our sine function originally started at 0, 0, and up, but instead we backed up by a pi over 4 unit and did it there. Okay, that is the end of the sine graphs. We will do cosine graphs after this.